Okay, and then I think that it actually has the correct. Yeah. And look, I didn't have to do anything with it again. That's 2 times now.
We we did it.
We did it. We did it. Guys, this is Fraser. We were
Hey,
watching
everybody.
we were watching some of your videos in slow-mo yesterday.
Slow-mo.
Especially that Q&A part that's now become a meme of this channel.
Right.
And it was
Great.
amazing when you read
I
it
have
in
a
slow-mo.
new QA that's about to go live, although nothing in it is as hilarious as that.
Yeah. I know, that was great. That was absolutely wonderful. Everybody was loving it. We were
Yeah, I try to
cracking up.
pick like two of those every show. Every question show, I sneak into witty retorts to someone being an asshole,
Yeah. Yeah.
or uh, or someone or a bizarre non sequitur rabbit hole conversation. So those are also funny.
Yeah, absolutely. They were great. And I don't know if we're gonna there's some that we still haven't watched. We still haven't watched the new Planet Hunters one that you put
Ooh,
out
that's a
over a
good
week ago.
one.
I know.
That's the good one.
I know. We have not. Not magic is opposite. That's right, Danny. So how's everything been going?
Great. This week has been a lot more chill.
Mm-hmm. Oh
But then
yeah.
it's been very busy because I've been trying to catch up everything that I had to throw out had to throw off to the side while I was trying to make last week happen. So it's been good. It's been good.
Yeah. And there was some cool news with well, I retweet a lot of it, guys. Universe Today has a wonderful Twitter feed, and so does Fraser. Fraser tweets a lot of stuff with it, but there was one about the first molecule that they found.
Yeah, we're actually covering that now, so we should be having something about that coming out on the show, or sorry, on the website in the next couple of hours.
Oh wow.
But yeah, the first possible molecule. So back at the beginning, when all there could have been was helium and hydrogen, the only molecule would be a combination of helium and hydrogen.
Right.
And astronomers have actually found evidence of this molecule out there in space.
Yeah. And that's really, really interesting. I don't know if a lot of people picked up on that, but we hadn't gone into it just yet. But again, you said there's something else coming with that. We did watch, since it's Hubble's 29th birthday,
Yeah.
we did watch your discussion, because we get a lot of questions. I get a lot of questions saying like, so are the images that Hubble takes fake? I
Right.
think that's been the biggest question I've even had with the black hole. That one keeps reoccurring. Is
Yeah.
it same for
Yeah.
you?
Yeah, I mean, I get a lot of people just making this assertion that it's not a photograph,
Uh-huh.
which then leads me to begin this conversation about what is a photograph,
Right.
right?
Yeah.
Like your eyes have the rods and the cones, and they're getting jiggled by photons, and your brain is constructing an image of what it sees.
Right.
Um, Visual light is just happens to be photons. I wish again we had some kind of tattoo-based visual aid.
Oh.
Photons are just, visible light is just photons at the whatever 400, 800, nanometer
Mm-hmm.
scale, and you get, and that is the range that our eyeballs detectors can actually pick up. While radio waves are still photons, they're just at a different
Wavelength.
scale,
Yeah.
right? The color green is a photon of a certain type, while the color red is a photon of a different type. And so those three kinds of photons are coming into your eyes, and they are jiggling different parts of your meat, and your brain is constructing a picture.
Yeah.
And we call that seeing, while a digital camera uses a similar technique in that it has different ways of receiving the different wavelengths, and then it constructs an image based on the three colors and takes a picture, right?
Right.
Well, you can take a picture with radio.
Mm-hmm.
It's just that you can't use the same machine that to take a picture in radio that you can in for visible light. But at
Right.
the end of the day, it's all the same. It's the same electromagnetic wave,
Right.
just at different parts of the spectrum.
Right. Yeah.
And so when you see a picture from the Hubble Space Telescope, yeah, you could look at an image where they have arbitrarily chosen red, blue, and green as the three filters, the three wavelengths of light that they choose to show.
Right.
But you could also choose three different filters: the specific one for um, uh, energetic hydrogen, and the
Mm-hmm.
specific one that shows off sulfur, and the specific one that shows off oxygen. And you combine those three together. You say hydrogen is red,
Right.
oxygen is blue, sulfur is green. Put them together, you get a photograph like what you can see behind on my channel, right in between us right now.
Mm-hmm.
And that is three colors. That is a photograph made of three arbitrarily chosen colors.
Mm-hmm.
And you could have just as easily made the emissions from sulfur the red. And I see people do this all the time. And our brains are happening to choose just to display an image in a certain way. And so when we want a digital camera, or when we're wanting something that matches a representation of what we see as colors.
Mm-hmm.
But the reality is, of course, is that the only way to get an image of space is to take a long duration exposure.
Mm-hmm.
In the case of the one that was taken of the black hole, they had to take like the better part of a week.
Right.
Many images from the Hubble Space Telescope are hours and hours of integration. Again, your meat cameras are dumping all the photons that fall into them every 30 seconds at the most. If you're like
Right.
really dark skies and your eyes are really well adapted, then you're going to see something. You're going to see 30 seconds, and then your eyes will have emptied out all of the photons that it received. And so if you wanted to know what anything would look like, the way you would really see it, just look at a black screen. You want to look at what the Orion Nebula looks like up close, sort of like a little bit of like a whitish cloudiness to it.
You can see some of the purple.
With your eyes, yeah, you can. I mean, Orion is such a fantastically
It
bright
is.
object, yeah, that you can see a little bit, but still, they don't look anything like what you see in the photographs. And so, again, are they real? Well, it's just that if your eyes could see for longer, could hold on to the photons for longer, then they would look real.
Mm-hmm.
But they can't.
Right.
And so it's just when you see something in slow motion, is that real?
I mean, I feel like we watched a lot of things in slow motion yesterday. Yes, real. Absolutely.
Yeah, right. So I think that people need to get really clear about their definition and not have this sort of ad hoc response to it.
Yeah, I feel like the people that are saying that are also the ones that think like space is fake just in general.
Yeah, space is fake.
It's all
right?
fake, right?
Yeah, it's all fake.
Yeah.
So it's not for you.
Yeah, and so to ask the question, and I need to correct myself because I said, yeah, it's just radio, it's a different wavelength. What I meant was it's a different frequency, so it's a different portion of the EM wavelength. So it's all one wavelength,
portion
but you have
of the
different.
electromagnetic spectrum.
I just wanted to say that for all the YouTube comments that might come in, they're like, she said wavelength, and radio is a different wavelength. It's not. It's part of the EM wavelength. So why radio for this? Why is radio so great?
The radio. I mean, the main reason to use radio in this is that that's the only wavelength that you can make a telescope the size of the Earth.
Mm-hmm.
So, because you have to get the only way to make a telescope the size of planet Earth is that if you line up the wave fronts for all of your telescopes
Right.
so that you are perfectly aligned to the exact same wavefront. And essentially, you've got a tolerance of 1.2 millimeters on your wavelength.
Mm-hmm.
And the only way to do that is have really, really accurate clocks. And then after the fact, you go and you take all of the data and you line up to the time data, and then you line up everything so that you've got them timed down to the individual, to the correct wavefront. And so radio is the only one that we can do that right now.
Yeah, and is it because of its stretched out wavelength that it's more forgiving?
Yeah, 1.2 millimeters.
Yeah.
Right? Like you could see a 1.2 millimeter wavelength,
Mm-hmm.
as opposed to 500 nanometers,
Right.
which is visible light. So 500 billionths of a meter,
Mm-hmm.
right?
Right.
That's very small.
Very.
So can you imagine if someone gave you a bunch of pictures and said, okay, line these up to the 500 billionth of a meter, go.
Right.
you would have a hard time. But if someone said line these all up to the 1.2 millimeter, and there's a bunch of strips of paper, and it
Right.
was just a bunch of like thin lines and thick lines and thin lines and thick lines, and said line these up, you could do that. You could look at the various bands and you could line it up, and then they would be acting like one big telescope. But until you act like one, until you get them lined up, like I said, to the wavefront, they are not one big telescope. They are a bunch of little telescopes.
Mm-hmm.
So
Um,
that is the magic. And the other part is that radio waves are able to pass through the atmosphere nicely. So whether it's day or night, you can take a picture at the same time, which is great.
yeah, that's what
They don't worry
JD.
about the sun, so that's a bonus as well.
Yeah, JD just said that. Isn't radio less interactive with stuff in between
Yeah.
too? Yeah, like
Yeah,
our
you can. I
atmosphere.
mean, radio astronomers are happy to take pictures during the day
Mm-hmm.
when the clouds are out. Some clouds, and it
Some.
depends on the wavelength that they're trying to do.
Yeah. And oddly suggests I want to create a shield for our planet to stop meteorites from hitting us.
We have one,
What's that?
which is the atmosphere,
Oh,
right?
so you mean those aren't shooting stars?
What? They are. That's the point. The atmosphere stops the meteors from hitting us.
Yeah, no, and a lot of people don't know that. We always make jokes
Yeah.
about that. They think those are actually stars moving at that that rate across the sky.
Yeah, they only protect us to a certain point, and
Hmm.
then when it's big enough. So yeah, if you want to build a shield to make a planet safe, all you have to do is just surround it with a lot of gas.
Yeah. What about the moon base? What about the
What
moon
about
base?
what about the moon base?
What about it?
You mean the plans to send humans? Well, right now the only plan is to maybe send humans to the moon by 2024. But we're starting to see some budgets come back now, and people are saying that they're going to need things like uh, 5 times NASA's current budget and no changes in goals and timelines to be able to make it to the moon.
Mm.
So I don't like those odds.
Yeah, they were talking about putting it on the dark side of the moon.
There is no dark side of the moon
Well,
except in Pink Floyd,
well, for us, right? The side that we don't see.
the far side.
Right.
Yeah.
So they
Oh,
were.
man, I just sounded so snippy there, didn't I?
No,
Man, I'm the worst.
you're
I
so
apologize.
mean. He's so
I'm
mean.
super mean. Why do you invite me?
No, it's so I read that actually. Was it this morning that I read that they were talking about actually putting it there on the further side from us, or
Putting
that we
some kind of
see?
base on the far side of the moon?
Yeah. Am I making that up, guys, or did anybody else read this?
I'm gonna need to see you cite a source,
I know.
but that's I don't know. That seems. Let me see. Let me see what Google News says. Moon base far side.
Mm-hmm. Mm-hmm.
China? No. No, I don't see anything new.
Where was it? Was it on my Twitter? It could have been on my Twitter feed. And I don't know that. So, and oh God, I don't want to have to go through my Twitter feed. Moon. We'll just say moon and see if it pulls up something. Yeah, because they were talking about.
Someone's saying moon base at the South Pole.
That might be it too. I wish
Okay.
I actually had a reference. They were talking about. Because yeah, this is. I do need a source for that.
Yeah. Okay, there you go. So NASA plans to send astronauts to the moon's South Pole in 5 years. So is
Yeah.
that possible? What you were seeing?
Yes.
Okay. Yeah. I mean, the South Pole is probably the best place to go on the moon, and that was one of the reasons why why the Chinese rover went to that area, was to examine it as a place for a future moon base. Right.
Right.
There are these craters on the moon that are in eternal shadow. They're constantly covered by, like, the sunlight never falls into them because the moon, isn't able to show its south pole to the sun. And so there are these deposits of water, and they've determined that, yeah, there is gigantic deposits of water ice that are going to be there at the southern side of the moon.
Mm-hmm.
And so if you want to set up a moon base, you're going to want to you're going to want water, access to water, because water is life. Water is stuff to drink, food to grow, fuel, air to breathe. All of that comes from water. And so you want to go to the South Pole of the moon to set up a moon base. But I wouldn't see, like, if they do return in the next 5 years. I mean, it would be great to go to the South Pole. I think that's the natural place, but I would be surprised if that's where they start, because it's a little more technically challenging to go down there as opposed to landing in a nice, obvious, safe location like they did with the Apollo
Right.
missions.
Right.
Yeah.
Huh.
So, but
No, oh yeah,
um,
here it is. The NASA plans to send humans to the icy part of the moon for the first time.
there you go. Yeah.
Yeah.
The
Okay, that's the
interesting
South
thing,
Pole. Wow. Okay.
yeah, I saw someone quote and say that in fact, if you were thirsty on the moon, you could extract more water from concrete than from lunar regolith.
Oh wow.
It's that dry on the moon. So yeah, if you've got some concrete kicking around, there's your water source, as opposed to um, the lunar regolith itself, which is why the water ice is going to be, the water is so critical.
Mm-hmm.
And we just use it for so many things. You split it apart, you get oxygen to breathe, you get hydrogen and oxygen for rocket fuel, you drink it, etc.
Yeah, I think I was getting confused with the someone said whiskey actually said I know China put their rover on the far side. Yeah.
Yeah, well, China put their rover on the far side, but down in that region.
Okay.
And so you can see them really considering the same target. And I think we talked about this last week, right?
Mm-hmm.
Like, it
Yeah,
really
yeah.
feels like the Americans' uh, rush to get back to the moon has got something to do with the Chinese. Like, the
Oh yeah.
Chinese are just relentlessly continuing on with their process to land humans on the moon. That's their plan. They're building up the hardware, and they're going to do this.
Oh yeah.
Now the United States has been wandering around without a goal for 20 years, and now they're like, what if someone beats us back to the moon?
Yeah. JD asks, is regolith just what's on the surface, or does that include all the subsurface goodness?
Yeah, the regolith is both, is the term for dirt on the moon or on Mars, because dirt, earth, soil here on Earth includes both ground up rock, but as well as decaying organic matter, right?
Mm-hmm.
Leaves, plants, etc. And you don't have that on the moon. You just have ground up rock. And so the term for that is that, and that's what you call it. You call it regolith. Regolith is just the 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 material that you would find on the surface of the moon
Yeah.
or Mars, because
Uh,
without any organic material in it.
yeah. I read recently that meteorites kick up a lot of subsurface water on the moon.
I have heard this as well, that there is, I don't know if it's a lot, but that there is a, essentially, when the meteorites strike the moon, they are kicking up hydrogen and oxygen that had been trapped as separate atoms on the moon, and then they are able to combine into water, and then they get blown away by the solar wind. So you've
Mm-hmm.
got this really faint haze of water molecules that are being generated around the moon, but nothing that you could use.
Gotcha. Yeah,
Yeah.
yeah. Moon dust is abrasive and really hard to get off from the
Yeah,
surface.
this is one of the biggest risks that we still have to face, is that this stuff, if you look at the regolith in a microscope, it looks like little pieces of glass,
Yeah.
and it acts that way. So when you breathe in, if you've been out on the moon and then you come inside and you dust off your spacesuit and you breathe in the material, you're going to get the same kind of lung infections that miners get, like coal miners get. And it's looks like it's really serious stuff. And so all of the astronauts, when they spent time on the moon, reported like cold flu like allergic reactions to this stuff,
Oh,
and because it goes into your lungs
lungs.
and then embeds like little pieces of glass. And so any long-term habitat on the moon is either going to have to, um I'm not kidding, sweep the moon, right?
Oh my God.
Yeah, like, because it doesn't move very much.
Right.
There's this electromagnetic, every day that goes by, you get the moon dust sort of raises up from electrostatic, this electrostatic field, and then
Hmm.
can be moved a little bit. But yeah, you would want to clear off the moon dust all around your moon base so that for regular maintenance that you're doing, that you're walking around, you're not going to be picking up a bunch of this stuff. And then you would need to probably have your spacesuits built in such a way that you can get in and out of your spacesuit, but it never gets into your moon base
Right. Right.
unless there's some really rare situations. You've seen these examples of spacesuits where people have to have crawl in the back of them and then they can close it up and then away they go on or walking around the moon. And that's what they'd have to do because you do not want this stuff building up inside. You could sort of imagine some filthy, and they were saying, the Apollo astronauts were saying this stuff was getting everywhere,
Oh my God.
right?
It's like the asbestos of the moon.
Yeah, it's the asbestos of the moon. You can just imagine the future lawsuits if they can't get this figured out.
Oh yeah.
So,
Oh yeah. We see them all
yeah.
the time on daytime TV still, right? I
Yeah,
feel.
exactly, right?
Yeah.
Mesothelioma,
Right.
but on the moon. Moon is the thelioma.
Yeah. I feel like they should make little moon sweeping robots.
Yeah, yeah. So just sweep the moon.
Yeah.
And it's funny. Someone asked me that as a question in one of my question shows. I'm like, yeah, that's not a terrible idea. Sweep the moon.
Yeah.
Sweep it
Maybe.
up. And then the other thing is, I mean, of course, the reality is you're going to make robots do your exploring and all your outside work, and you're going to be living in your lava tube.
Mm-hmm. Yeah.
Underground that you cleaned up, that you swept.
Let's see. There is someone else said that. How much does the job pay? Isn't that lunar rover having suits have that back door? I think
Yeah.
that's what you were talking about, right?
Yeah, and that's what I was mentioning. So there's some designs where you've got like a Mars rover or a lunar rover, and the spacesuits are sort of like they're bolted to the outside of the rover, like they're dangling on the outside of the rover. And what it is, it's like a little door. You open up the door, you get into the spacesuit. Someone closes the back behind you, and then you disconnect from the rover. And now you're walking around outside on the moon, but your spacesuit never comes into your habitat. And it's a
Interesting.
pretty great idea.
It is.
And it's less dangerous with Mars because the moon has no real weathering.
Right.
So the moon is just like I said, ground up shards of moon glass.
Right.
While Mars has, constant wind that just blows the particles around and smooths them out. So that stuff will get into everything and get really gritty, but it won't give you black lung in the same way that the moon will. So just be careful when someone says, hey, do you want to go live on the moon? Just make sure they've sorted out that whole regolith
Yeah,
problem.
just housekeeping gets called ahead of time.
Yeah, exactly.
So
Moon lung. There you go. That's the name.
moon lung. Oh God. Mythic
Oh,
asks,
you got a bad case of moon lung.
do we need decontamination chamber where robots scrub your suit free? That would
Yeah,
also be a
so
great
if you
idea.
are going to bring your suit into your moon base, and I do not recommend it, then you're going to need some way to do that. Like maybe you take a shower and it sprays off and somehow collects all of the moon dust, and then you can pick it up off the ground. So yeah, whoa, you need to wipe that suit before you come in, young lady. Yeah, or you're going to kill us all with we're all going to get moon lung.
Yeah, I actually
That's
had not
sticking.
heard about that it's almost like a asbestos type shard. That's crazy. Let's see. So we have some kind of pseudo stuff going on, and why is that? Yeah. So with Mars, it's more like a dust, right? It's a very fine dust.
Yeah, but the trick is that just because the wind is blowing, the stuff gets tumbled
Everywhere.
around and is smoothed out. So it's still this gritty red dust that's going to get into everything, but you're not going to breathe it in and then have it stuck into your lungs.
Right.
It's going to be like sand.
Yeah. So, question. So I did see that you retweeted there was the picture and exposure. Was it like 1,060 hour exposure of the Large Magellanic Cloud?
Yeah, that was amazing.
Is that actually record breaking? Is that the longest exposure?
Oh no,
Okay.
like amateurs maybe. I don't know. No, like 1,060 is a long
It's a
exposure.
long time.
Yeah, like I was thinking about Dustin Gibson over at OPT,
Right.
and he did a 90-hour exposure of the Helix Nebula, and it's just amazing. and that's 90 hours, and he's a maniac.
Right.
So I'm 3 astronomers gathering 1,060 hours. I don't know. Like the Hubble Deep Field. How long was the Hubble Deep Field?
Well, that's a good
Like
question.
it's uh, weeks of work. Let me see how long they did the Hubble Deep Field for.
Anakin wasn't kidding. The sand gets everywhere.
22 days of exposure time. So what's that in hours? 528 hours. Wow, that might be a record. Yeah. So
Yeah.
that's like 44 straight days of exposure time. And of course they could only shoot at night and only times when the Magellanic Clouds are above. So that was probably like a year of work to produce an image like that.
Yeah, because I think it was yeah, which it might be the world's longest exposure in amateur astronomy.
Yeah.
For everybody that doesn't
The
know what we're talking about,
extreme deep field. I don't know what the length for the extreme deep field is. All right, let me see. Now I want to know. Hubble extreme. Sorry.
Oh, you're good. Have you seen the series Planets about the human race just starting to colonize space? It's Japanese.
Nope, same thing.
Oh, really?
Yeah.
They did the same exposure time for the extreme?
No, like that is the each deep field builds on the previous one.
Oh, okay. I didn't know that.
And so the Hubble extreme ultra deep field, but that was done in ultraviolet. Yeah, it sounds like this was longer. That's kind of amazing.
Yeah, it's pretty cool. And it's what's crazy about it is trying to sell this as the LMC. It doesn't look. It looks like something an artist did.
Right. Well, the thing is like the greatest locations of star formation are in the Large Magellanic Cloud.
Right.
And so what they've done in this picture is they have sort of reduced the brightness of the stars to really show all of these regions of star formation, including the Tarantula Nebula, which is that part that's down in the lower left there.
Mm-hmm.
It's a stunning picture. I mean, it is definitely one of the finest pieces of amateur astronomy that I've ever seen.
Yeah, it's amazing. That's not a photograph.
Yeah, it's not a photograph.
That's not real space.
Yeah. Yeah, it is. Well, so what is it, right? I mean, I would have to. Can you hold your mouse over it again for a second? Over his description of it?
Yeah, he says it's a 1,060-hour image of the Large Magellanic Cloud, absolutely mind-blowing. Which
and go to his source. So go to his Astrospace dash page. His link there. Yeah,
with all of this stuff in it.
Yeah, and then let's see what he did it with. How he did it. Now, because so keep going. Down. I want to see.
Well, it has 204 million pixels.
Okay, here you go. So go back up. Okay, so you see there it says the hydrogen alpha line at, and then the sulfur. You're kind of blocking the part that says it, and then the oxygen line at 500 nanometers. So they used 3 filters: hydrogen alpha, sulfur, and oxygen at 656 nanometers, probably red. 672 nanometers would be green, and then 500 nanometers, and that would be their blue. And then they did a total of 1,070 hours of time. Usually you do more on the sulfur and the oxygen to balance the brightness of the hydrogen alpha. So they would have put in probably more of their time on those last 2 to get their color. And then the key is they just took, and I'm not sure, do they say how long each exposure was?
It looks like they're saying.
So, I mean, generally they probably
a few hundred hours to get out of the image.
No, but that's a combination. So what they'll do is they'll take, say, a 5-minute exposure in hydrogen alpha, and then they'll take another 5-minute exposure in hydrogen alpha, and then another one, and then they'll use program like Photoshop or, a specific piece of software that will then let them average it out. So
Look at this website.
yeah, okay, here we go. Go back down so we can see the actual technical data. I don't know if people care. The point is they did this. I'm assuming this took them the better part of a year to actually take the picture, to gather all the data to take this picture. And then they spent an enormous amount of time reducing the data and being able to pull it together.
Yeah, it looks like it's all in French, which it's
Yeah.
like that's totally fine. You can still
Yeah.
tell you have the oxygen 3 there, you have the
Yeah.
H alpha.
Yeah. And so they're showing the number of, looks like they're taking 336-second exposures,
Hmm.
but also 976 exposures. And they were, so you got the 336. You remember we would take pictures when we do the star parties. Remember when we used to do star parties? Good times.
Oh yeah, I
And
remember.
we would be like, let's do a 60-second exposure, or let's do a 120-second exposure,
Right.
or let's when we really wanted to go crazy, we would do a 300-second exposure. So
Hmm.
they were doing a 300-second exposure. But they would just do thousands of them.
Oh yeah.
And then there you go. They did a total of 9,936 separate exposures.
Right.
And then they would average out. So they feed that all into a computer and tell the computer to say, look at all these pictures and tell us what is data and what is noise.
Right.
And that's how you get a picture that amazing. And so really, really subtle features start to appear over time when when you've taken 9,000 pictures of the same thing, the computer is able to go, okay, that's probably nebula there, and that's probably star over
Right.
there, and that's how they do. So is that a photograph?
Is that
Right?
I would say so.
Of course it is. So that's how they took the picture. They And if you had eyes that instead of seeing red, green, and blue, saw hydrogen alpha, sulfur, and oxygen emissions, and you could watch the sky for 1,070 consecutive hours.
Yeah.
Like every night, just as the sun was coming up, you close your eyes and you come back out the next morning or next night and open them again and go back and stare at the Large Magellanic Cloud again. Then yeah, you would this is roughly what you would see after having done that for 100 consecutive nights.
Yeah. Bill has a telescope question. With cameras, when I see 160 millimeters, I think focal length. But am I correct that it seems more common to describe telescopes by aperture width instead?
Cameras, yeah. So when I wish I had a camera nearby me. Yeah. So when you describe a telescope, or when you describe a camera millimeter, you are generally you're measuring sort of the length of I forget the term, but if it's like a 4 millimeter, it's sort of like that's the distance from where its observing lens is to where it's gathering the image. And if it's 20 millimeter, you've got a bigger distance. And if you've got a 60 millimeter, you've got a bigger distance. And if you've got a 200 millimeter lens, they're starting to get really long, right? While a telescope, often they're quite long, or sometimes the light is going to bounce a couple of times inside of it, and you can change the focal length of what your telescope is. But at the end of the day, really, it's the size of the aperture,
Yeah.
the total size, which really defines how much light is getting in for you to be able to see. And so that's why you can buy a 50 millimeter lens that is, say, if you want to buy like just a straight up 50 millimeter lens, you can pay $125 for a mediocre one, or you can spend $2,000 for a really good one. They're both 50 millimeter lenses. The difference is the size really just the size of the glass.
Yeah.
The 50 millimeter is small. The $125 one is small. The $2,000 one is big. And so with telescopes, just bigger is better. And so that's why most people just focus on the the overall size of the glass.
Yeah, how much light it can actually let in. Um, the mass in that glass. Someone asked,
The mass in the glass. Yeah,
yeah.
exactly.
Um, someone asks, why do we even care about what we can do now and not what about actually what we could do? Oh man, he's talking to the wrong two people. uh,
Wait,
he
wait, hold
said,
on.
why are humans so small minds? Why not go full Musk mode and actually do something?
Like what? Like how about have rockets that land on their launch pads?
Yeah, that
That's a
was pretty
thing.
amazing.
Um, so Israel just launched a spacecraft to the moon, and we saw that it crashed last week.
Hmm.
And imagine there were people on board, right? I mean, they had, in order to make this mission work, they had removed a lot of the kinds of redundancies that you would need. So if you want to go fast, your choice is, do you want it to be safe or do you want it to be fast? And people don't have a lot of stomach for not safe. Like like the loss of the Challenger in 1986
Yep.
was a horrific accident. The loss of Columbia in 2003 was a horrific accident. 2001, 2003. Anyway, was a horrific accident. We see the consequences of when space flight fails. We know that it's risky, but it doesn't need to be unnecessarily risky. What's the point of that?
Right.
So I think that, and so you saw what happened with the Falcon, right? The so far 2 Falcon Heavies have launched, and they haven't been able to capture that central core yet. The
Hmm.
first one went into the ocean. The second one went into fell over on the ship.
Right. Right.
So I think that is the uh, Elon Musk is going as fast as possible and decreasing the prices and iterating as quickly as possible. And even that is, we're showing, they had one that blew up on the launch pad a couple of years ago.
Yep.
So I think the pace right now is fine. Like if you want to go faster, stop building weaponry.
Yeah.
Right? Pull some of the $750 billion that's spent on weapons and spend some of that money on exploration and access to space.
Hmm. Yeah. Um, back to the picture.
Vivek
Someone.
Frost is saying the Cinder landed, but it fell on the transport, but it still counts as landed. Don't count your rockets till you've got them firmly in your in port.
Yeah.
Yeah, until then, that's like a slow, like just imagine it landed and then it slowly fell over.
Yeah. Uh, I'm sorry. I'm trying to. There was a question about the picture that I don't want to skip. They asked if do they normalize the visual spectrum, bluer for shorter wavelengths versus redder for longer, so it would reflect the meat cameras what we see pretty well.
In general, they put them in that order, right? We
Right.
saw that they were using the spectrum for hydrogen alpha for red, the
Right.
spectrum for oxygen for blue, and the spectrum for sulfur for green. And that's they call that the Hubble palette. And so that generally, when you see a picture from the Hubble Space Telescope, that those are the colors that they are using, is those spectra.
Mm-hmm. Uh, so let's see. The winds knocked it over. Tell you got your rockets until they're in your pockets.
Yeah,
I'm trying to see. Was there any other questions with that I missed?
rocket in hand is worth doing the surf.
Um,
I mean, for people, like, I get that people are impatient, right? Like, that's the reality. Is they'd be like, I want it now,
right.
and and I think for the young people who are impatient today, you have no idea how long we've been waiting, right?
Oh
Us
yeah.
old folks have been waiting almost 50 years. I haven't waited 50 years, but 1972, it's been almost 50 years since humans set foot on the moon last time. And we were supposed to go there and supposed to stay.
Mm-hmm.
And now we didn't. And so I get impatience. And in fact, most people who know me know that I am literally the human embodiment of impatience. But but I want them to be safe.
Yeah, I agree with
I
that.
want it to work in a way that people don't turn away again because of the cost and the expense and the death.
Hmm.
I want us to move forward in a way and this time to stay.
Yeah. Uh, Beaver asks, why don't meteorites destroy the ISS and satellites?
So if you look closely at the ISS and satellites, they've been sandblasted. And so there are tiny particles that are hitting them all the time. And you can actually, the longer, like the International Space Station has been around so long that there are big chunks, I mean like pockmarks, like, that you would dig out with a little chisel on their solar panels and things like that. And when the space shuttle came back, you could see all of the little impacts that happened on their front windscreen.
Uh-huh.
So it's a constant risk. There is a non-zero risk every day that goes by that some either piece of space junk or a meteorite is going to strike the International Space Station and cause a catastrophic impact.
Yeah.
Now they have mostly researched all of the particles. They know where all the big pieces are, and the smaller pieces essentially it's got enough insulation and protection, like armor, that it can handle a direct strike from a bunch of those things. And if they detect any big piece coming their way, they'll actually move the space station to be able to handle. There you go.
Yeah.
Yeah,
I saw this
that's
earlier this week.
yeah. That is what you get when you shoot. Was it? That's a
Uh,
5-inch deep crater created by a chunk of, I
at
don't know, like
15,000 miles
a
per
half
hour.
ounce piece of space debris into a block of solid aluminum.
Yeah.
So if a chunk of if a half-inch chunk of space debris hit the International Space Station, think of the damage that it would cause. And
Yeah.
so right now, NORAD and NASA and stuff, they are mapping. They have located every centimeter sized piece of space debris out there. And if any of them are on their way in any kind of uh, orbit that's going to strike the International Space Station, they move the station.
Yeah. So they say it's something about the size and weight of an eraser on the end of a pencil,
Yeah,
going about 15,000 miles per hour.
yeah,
Yikes.
and that's what it does.
Oh, man. So what are
Yeah.
they going to do about, like, someone just said here that with the Israel spacecraft that crashed is now space junk.
No, well, I mean, it's space junk on the surface of the moon.
Right. And he
Yeah,
says cleaning up
it's
our
a
expensive
new.
space junk should be priority.
No, because it's stuck. It's stuck to the moon, so you don't have to worry about it. I mean, you can go visit it if you want, but it's not going to be moving around in space. It's there. It's done. It's it's part of the moon now.
Mm-hmm.
The moon has cleaned it up for us.
Yeah. Yeah. So I have another question for you. There was an article we were reading earlier this week that Pepsi is planning to use CubeSat technology to advertise in the
Uh huh.
sky.
Yeah.
What do you think about that?
Well, they have said they never planned that. Although Futurism has some pretty good reporting to show that in fact maybe they did.
Mm-hmm.
Um, and they have since totally backed away from this and said, "Don't worry, we're not going to do it." But
Okay.
I mean, just because Pepsi won't do it, this underlying company is still planning to run tests of this. So if Pepsi might not want to do it, but I'm sure there's going to be someone out there who'd be glad to pay them to advertise in space.
Yeah, everybody was saying, like, how could this even happen? Is this even possible? Won't people try to stop it?
See, now we know why India did its test of an anti-satellite rocket system. Everyone thought they were so bad, but actually, maybe they've got our backs. They're gonna destroy it.
I will declare war on any brand that puts an advertisement in my night sky. I
Yeah,
know.
yeah,
Yeah.
yeah. Just imagine how this picture would have looked with all of those times that the ad moved through the
Oh my God.
the picture.
Yeah. Like a freaking ad in the sky. Yeah. Mm-hmm.
Yeah,
Yeah, we were talking about that earlier. Pepsi
yeah,
Company, there was something with that.
yeah. So I think
Um,
so at this point, Pepsi isn't the risk.
right.
It's the company that had sold Pepsi on doing a test and is still planning on doing this kind of horrible thing. That's the risk.
Yeah. So who owns space? Can anybody launch rockets on the scale of NASA?
Uh, the Outer Space Treaty defines what you're allowed to do in space. And those were signed by most of the nations on planet Earth. And mostly they're about not launching nuclear weapons into space.
Hmm.
But you can't own space. You can't own a chunk of the moon. You can't own Mars or an asteroid. If you build a base on one of those places, you have to allow anybody to be able to um, uh, use it if they want to, just like Antarctica. And if you plan to launch a rocket, then you're bound by the rules of that country.
Right.
So, whatever, if you, it's sort of the way ships work, right? Like if you take your ship, you fly under a certain flag. And so you're bound by the rule. If you fly under a Dutch flag, you are bound by the laws of the Netherlands.
Hmm.
And yet there are rules for being in international waters. But if a country has not signed the Outer Space Treaty, then you've got to stop them from launching rockets. Right?
Hmm.
Like if North Korea, I don't think North Korea has signed the Outer Space Treaty, but China has.
Hmm.
So China's not allowed to launch nuclear weapons into space. But
Yeah.
say North Korea hasn't signed the treaty. So if North Korea launched rockets, sent astronauts, started to claim parts of deep space, you would have to physically stop them if that's what you wanted to do, because they have not signed the treaty, and the only way to stop them would be to stop their rockets and their efforts.
Yeah. There's a lot of good comments and questions that are coming through. One person said, my favorite YouTube video impacts and what would happen if a meteor hits Earth at the speed of light. Okay.
Don't. Boom.
So if you're in space and you need to use the restroom, right, you can't go knocking, or you can go knocking on anyone's station. I don't know about
Mhm.
that. Can you?
Yes. Yeah.
Really? So
Yep.
then why aren't we being nice with China and the ISS and all that? Like we didn't.
If if China got up to the International Space Station
Uh-huh.
and the astronauts knocked on the door, the astronauts, according to the inter to the Outer Space Treaty, would have to let them in and
Oh,
feed them dinner.
I did not know that.
Hmm. Yeah,
Um, so then someone said, what happened to the one company who launched without a permit?
that was actually an American company, and they launched on an Indian rocket, but they didn't get the approval from the FCC.
Mm-hmm.
Anyway, the American group that defines the use of airspace above the United States. And so all American companies, if they want to operate, FAA, yeah, if
FAA,
they
yeah.
want to operate in the United States, they have to get the approval of the FAA. So even if you're going to go and launch in, sorry, I'm Canadian. we, we,
Yeah.
we don't
It's
we don't
okay.
have these things. Yeah. So if you want to operate your business in the United States, you have to work under the FAA's laws, or the government will shut you down. And so they were an American company, so they really lost. Uh, they lost out on that, and they got punished. Well, the part is that like the FCC actually does have part of it as well, because they deal with the transmissions of these satellites.
Mm,
So the FAA defines sort of the launch and safety and things like that, and the FCC defines if these are going to be doing any transmissions. So
yeah.
I'm going to say that I'm half did a mental typo.
Yeah. There is. Oh, it's fine. If you bring anything back from space, you must share some part of it with other countries, as I know. There's an international law about that.
Yeah, yeah. So again, anything acquired in space, there are rules about how you must make it available to research, uh, to other research organizations if it's done as scientific research. There's It's a wide open territory though about resource acquisition. Like if you mine an asteroid and you drop a gigantic ball of platinum back to Earth, um, do you have to share?
Hmm.
If someone wants to study your space platinum, then you do have to share some of it. But if you want to just spend it, I don't think people can make you share that.
Right.
So
So
no,
I
you can go and mine space diamonds and be rich.
um, let's see. There is another one too. Oh, well, this someone was asking. So DPI was asking Bill, but it's a good question. Define viable space program. Also, would you count only nations that have launch vehicles?
Well, I mean, keep in mind that it's such a weird world now, right? That you can hire a you can hire an American company. No, let me get even weirder. You can hire a uh, you can buy a satellite built in the United States, which will then be launched on a European rocket from a South American country.
Huh.
Right? So, I mean, we live in a global world where people can put together every part of this. So, I think that even if I mean, the Falcon Heavy launch was an Arab sat, there's been Pakistani satellites, there's been African satellites, and they just pay for launch to space just like um, any other customer. So, same thing, a nation might not have the ability to make their own cars. They can still buy them.
Right. Right. If you want to have it really weird, the rocket would be built by Russia.
Yeah, yeah, yeah. Rocket built by Russia or in the United States, right? Just yesterday, an Antares rocket as
Hmm.
well, a rocket rocket carrying a NASA payload launched from the east coast of the United States with Russian built rocket engines.
Hmm.
Yeah.
Yeah, I think I saw something on the space Reddit about that.
Yeah, the RD-181s.
Uh, let's see. South American country launching Russian rockets.
Yeah.
uh,
Yeah, you can have Soyuz, and Soyuz is launching from French Guiana in South America, carrying a payload for the United States, but usually Europe. But the James Webb is going to launch on an Ariane 5 rocket from French Guiana because that at the time that was the only place you could launch them.
SpaceX would have a much easier time if Falcon was lighter.
I, I guess I don't know if they want
Yeah.
they they want it to be strong. They want it to be a ridiculously powerful rocket.
Yeah, exactly. Um, International corporation, what kind of hellish nightmare world are we living
Yeah,
in?
one where
uh,
we all work together. It's like the Federation of Planets. Welcome to the
ooh,
future.
that's a good question, Auntie. When do you foresee space tourism being an affordable thing?
Define affordable. um, uh, the let's see. So, I mean, right now, probably on Virgin Galactic, if you want to take a flight on their rocket, you're looking at about $250,000. If you want to fly on Blue Origin, which is going to be doing this sort of rocket flight up, parabolic flight, and then land on its landing pad again, you're probably going to need about 100,000.
Mm-hmm.
So you can imagine over the course of the next, and right now there's an orbital flight. If you want to pay with like space adventures, you can pay 20 million to 40 million dollars.
Mm-hmm.
The people who are going to go, the Japanese guy was going to go around the moon. I don't know if that's still going to happen. I think they were going to pay a few hundred million. So yeah, I mean, if you're a billionaire, then that's affordable. But I
Right.
think for regular people, you are looking at it's going to be decades before you can, for say $10,000, be able to ride a suborbital flight and have a good time and experience zero gravity
Kids in
and
college
disprove the flat Earth.
or a really cool rocket flight. Hmm.
Yeah,
Um, and I think there was some other ones maybe up here.
the answer is
Um,
obviously really cool rocket flight.
yeah, yeah.
Sorry, kids.
I know, I know. Uh, paying to get cred behind my eyeballs. I don't see the problem with sending humans into deep space. We send soldiers into war every day. There are probably more dangerous jobs out there than astronauts.
Um. Okay.
I,
Uh.
um,
Yes.
yes.
Good. Good. I mean, so like I mean, what do you want to say right now with our current levels of technology? Uh, we have various health issues that happen to astronauts. Anyone who's there for up in space for any period of time start to experience problems with fluid redistribution, problems with their eyesight, problems with their cognitive issues, and that's just like floating around still in the International Space Station. We've never seen anyone go out to beyond Earth orbit for any length of time. There are solar storms that will pass through on a regular basis that will provide a lethal dose of radiation to an astronaut. And that's just not a question of when, uh, if, it's a question of when. So yeah, so let's imagine you send out astronauts
Mm-hmm.
into deep space, and every 6 months or so they all die. Always. Right there,
Mm-hmm.
are you willing to? Is it okay that astronauts only live for 6 months and then they all die? Is that the price you're willing to pay?
Right.
Because there are solar storms that powerful that will deliver that level of a radiation dose to anyone in space who isn't protected.
Right.
So
Right.
you just got to decide. Like, yeah, if you want astronauts to go up and live for 6 months and then die from radiation exposure or whatever, I don't want to. I don't want to be in your space program.
Yeah. Yeah.
I
Bill.
want the one where people have taken a long time and they've figured out ways to have shielding, and they've figured out how to rotate their space stations or spacecraft to provide artificial gravity so that they can reduce their risk while they're out there in space. That's what I want.
Yeah. Bill
And
says
at
high
some point,
energy
it's always going to be dangerous. I mean, space is the
is,
worst.
yeah,
It is
space is
really trying to
bad.
kill you. It's just a matter of how much are you willing to what are you willing? I mean, you're saying it's their choice as long as they know the risk, just like being a soldier. Yeah, I mean, for sure.
Yeah.
Yeah, the risk is you you get to be in space for 6 months and then you die from radiation exposure.
Yeah. High energy cosmic radiation packs enough punch to knock the nucleus out of an atom. Yeah, there's going to be risks, right? Yeah,
Mm-hmm.
exactly.
So the question is like,
Exactly.
which of the risks are worth taking? And so
Right.
when you think about the military, right, the risk is, yeah, your risk is that your soldiers are going to die, but but what you were trying to prevent is, say, your country being annihilated, or there being like, whatever are the, and I'm not going to argue whatever the underlying rationales for war, cheaper oil, whatever, right? The point is that militaries make a decision on,
Mm.
and the governments make a decision on whether it is worth risking human lives for whatever are the targets, whatever are the plans, right? Whatever the goals, the objectives. And so the question is like, would you be willing to risk your life to bring a rock home,
Right.
right?
Mm-hmm.
And
Um,
so some people will go, yes, no problem. Show me the rock you want brought home, and I will accept that lethal dose of radiation to bring you that rock. Other people won't.
right.
Yeah, how shiny rock?
How
Like,
shiny.
really not very shiny. Yeah, it's just from the moon. So I think that it is always risk reward,
Right.
and we will just have to. And my preference is to be safe. And NASA, I think, has spent a lot of time trying to figure out how to be safe, and at the same time to also not waste time doing things that aren't core to what I think is the mission of exploration. And I
Right.
think that's the thing that NASA hasn't done is they haven't been given the freedom to focus on exploration. They've been given bad goals, and
Mm-hmm.
then had the rug pulled out from them, and then haven't been given the budget to accomplish the bad goals that they've been given. And so I think that's my preference.
Yeah, and David, that's actually a really good question. There was another one that would be really off topic. We don't have much time left, but aside from space tourism, when or if do you foresee non-scientific civilian jobs in space or on the moon, like janitors, maintenance,
Yeah, I mean,
meter
we're kind of
watcher?
already there. Like when you look at what an astronaut does, they are. It's funny. Like you talk to Mike Massimino, who worked on the Hubble Space Telescope. He's an engineer, astronaut, but really what he was doing was fixing the Hubble Space Telescope. He was a space mechanic. So I think that for a lot of what astronauts do today, a lot of it is that they are doing space. They're doing very complicated, very delicate, very highly trained, mission critical versions of the kinds of jobs that people do on Earth.
Mm-hmm. I would also like to dispel this myth that the military ever looks
Yeah.
before jumping. There are plenty of operations and training exercises scrubbed for safety issues. No Space Force officer worth his or her salt would ever send anyone on a 6-month suicide mission.
Yeah, I think in general, militaries are aware of the price of human life,
Right.
and because many of the generals have experienced war firsthand, and are very reticent to put human lives in harm's way unless they feel like that is what they have to do.
Mm-hmm.
They have trained to take lives and trained to sacrifice lives, and in general, pardon the pun,
Mm-hmm.
are understand the consequences of those actions. So
Bill being Bill. God, I swear he just makes everything he says just makes me laugh.
Neil Armstrong doing anime girl baby steps, crab walk in a spacesuit is now in your head. Yours too. Yeah, he did it.
Oh, it's a good question, a good one to go out on too. Even though we're 1 minute over, if you don't mind answering, would you
I
take
am watching chat EPL 2009.
Mm-hmm. Would you take the opportunity to go up into space today, Fraser?
No way. I'm
Me
way
neither.
too much of a coward.
Me too.
Yeah.
Me too. Yeah. But thank you so much for your time today. And
Oh, great.
yeah,
Always goes so fast.
It did. It went super fast. I looked down at the clock. I'm like 2:50. What?
We did it. I'm about to drop a new QA in like the next hour.
Okay.
So
Awesome. We'll be looking for it because we're gonna watch that Planet Hunter one right away
Yeah,
after
it's a good
we're
one.
done here. Yep.
Yeah.
Yeah, we have to.
Yeah.
Okay. Well, thank
And
you
then
so much.
Monday's live stream. I don't think you'll want to show that one. Was
Why?
just Chad, my editor.
Oh.
People always want to know who behind the scenes, right?
Uh-huh.
Who works with me, and so Chad and I did a live stream and talked to everybody for an hour. It was fun.
Oh. Yeah.
But Monday, I've got George Dvorsky, who is you had it on my
Yep,
homepage.
I did.
On my live stream. He is essentially the space journalist for Gizmodo and IO9,
Mm-hmm.
and he is the person who he originally had proposed doing dismantling Mercury and turning it into a Dyson sphere, and then that sort of turned into his he sort of was able to turn that into a gig doing futurism and space articles for IO9.
Mm-hmm.
And then the week after that is Jeff Notkin, who is Meteorite Man, and now he's the president of the National Space Society. So,
Yeah.
and he's just a delight, like one of the most fun people to talk to. So I think both of those interviews are going to be great.
Yeah, we have to.
So
you guys
join
can
me
set
on Monday.
reminders. Yeah. Mm-hmm.
Yeah.
Mm-hmm. And all of his information's right there. We're gonna watch one of them. Where do you find the Q&A? He'll likely let
I'll
us
post
know.
it on my YouTube channel. And
Yeah,
I'm
but
sure
yeah. But we'll be refreshing this too.
Yeah.
So, all right. Well, thank
Always
you so
a pleasure,
much.
everybody. Thank you so much. Where are you at on your subscribe? Oh, you crossed the line?
Yeah.
Okay.
Yeah. No, Arg Scott came in and gifted in 9.
Nice.
Yeah. So that
All
was
right.
amazing. So
All right.
All right. Well, I'll talk to you
Then I
soon.
won't have to shamelessly promote you.
Yes. We're good.
All right.
All right. See you
All
later.
right. We'll see you all next week, everybody.
Sounds good. Bye.